All right, I'm ready. How want to do tonight? Wanna good?
Yes, sir.
All right. So as early about 9 o'clock this morning, I'm having conversations about the question. In the afternoon, I saw 2 other queries, and it is suggesting me to 3 little misconceptions. Let me. How many of you did not do the question? Okay, Ramesh said that he didn't do it. Yani, put on your finger. You participated in my conversation today, so put on your finger. Unless you never do anything after the last conversation.
Sir, we never want Ramesh feel lonely.
You know, students like you, I'm telling you, or I should say classmates like you. Sash.
Yes, Senor.
Have you done my homework, ma'am?
Yes, Senor.
Okay, thank you. Alton, have you done my assignment? Have you done my assignment?
What assignment, sir?
Have a very good night, Alton.
I was not at the last class, sir.
Oh, you mean not at the last class?
I didn't get to make it at the last class. When I came in, my current was off, so I didn't get to make it at the last class.
Okay. I forgive you. You're not alone. Tiana wasn't here last class. Remember, in class I was asking for Tiana. Tiana wasn't here because she touched base with me. But you need to touch base with me and let me know. Tiana was able to touch base with me. So, sir, I was absent from class because of electricity problems. So you need to touch base with me and let me know what is what. So I'm gonna come across and load you. All right. You are forgiven. Yeah, man,
Sure.
cool.
Can I get a contact for you, sir? Sorry.
It's in the WhatsApp.
I don't think Alton is in the
What's up?
group.
I'm not in the group.
Drop your number in the chat, and my able assistant will add you to the group now. Jizam Tiana, there's something else I need to do for you, and I never remember today. Jizam, forgive me. I'll do that afterwards. Yeah, so just drop your number in the chat, Alton, and my able assistant will add it to the group, and then you see my number from there. All right, so yes. So on Tuesday, we had a meeting, an exec meeting that went beyond 5 o'clock. And it so happened that I was connecting the meeting via my cell phone. So it's when I was trying to get ready for class, I recognized that there was no electricity. So I'm fully aware. One minute, please. Right. So it's when I was trying to log on for class, I recognized that there was no electricity. So I was actually streaming from my cell phone for class for the early part. So I understand that. All right. All right, no. So goodness, what is it? All right. I need a volunteer. I need a volunteer to how do I do this? Hold on, give me half a second. Okay. Charlene, let me call upon you, honey. I want you to talk me through what it is that you are doing wrong, and what it is that you how it is that you understood your misconception, and I want you to share it with the class, because in sharing, chances are the other classmates may have the same problem, because there was another student who touched base with me this morning that was also having the same calculation problem. So walk me through it. Walk me through what it is that you were doing wrong, and tell me how it is that you corrected it.
Okay, sir. So, well, I already knew that once that your ordinals would be one greater than the number of trapezoids. So that was my issue. My issue was that with the upper and the lower limit, I remember that with the example that you gave, that used in order to get the number of ordinals, as well as what those the values of the ordinals would be, you started at the lower limit and counted till you reach the upper limit. What my misconception was that you had to count up by one until you reach the upper limit, not realizing that when we find I think it's the area, that actually tells you how much you should go up by when you're finding the ordinals. So that was where I went wrong.
When you find delta x.
Yes, sir. Delta
x, right? Very good. So I'm not finished with you yet. I'm just going to reiterate what it is that you're saying, because when you ask a question that, sir, that means something wrong with the limits, then it triggers a bell into my ear and said, this is going to be the problem. And the moment I responded to you is the moment you had the aha moment. And I recognize that you will not be alone, because others were thinking about it. Now, let me just, I know you're not finished, but let me just say something. And permit me to interrupt you, because this is a part of the learning process. I am sharing my screen to share. All right. So press pause, Charles, and look at it. So when I did this question, it could be misconstrued that because I was going up from, what was my question? I was going up from,
-1, sir. The lower limit was -1
to 2, right? So my ordinals were, call it non-fractional numbers. So it could have been misconstrued that in the questions that we're going to get, they're not going to be of a fractional form, right? But yes, you can have fractional forms. So whatever delta x gives you will tell you the width of the trapezoid. So that's why it's very important. Now, let me just reiterate this point. Maybe you're going to talk about that point, Charles, but let me just say this point before you even say it. If you need to say it again, not a problem. Congratulations for recognizing that the ordinals will be one more than the trapezoid. But in calculating delta x, you must get the number of trapezoids correct, or else your width is going to be wrong. Your width is going to be wrong. Now, let me just say something to you. Remember that question that Yanni asked, the very last question before we dismissed on Tuesday? She said, sir, before you go, I have a question for you. When you're doing an approximation, sir, with, for example, the root of 37, will you get an exact answer? And my response to her was, no. Remember the question said approximation, so you can get something that is close to. She said, okay, sir, that answers my question, because when I do the question and then I punch it in the calculator, I'm getting two different values. But guess what? One of them may get 1.46 and one of them may get 1.48 for argument's sake. So it's going to be a 0.02 of a difference. That's why it's called approximation. So what we're looking at now is applications of integration and the applications of integrations is to approximate or integrals without actually performing the integration. All right. So what is important is, remember I said to you, it's an approximation. When you crush your ice cubes to put in a cup of soda, those ice cubes will melt much faster than if you were to put the whole cube in the glass. Because when you increase the surface area, when you crush the ice, you're actually increasing the surface area. And when you increase the surface area, it means that the ice will melt much faster. What's the point? When you increase the number of trapezoids, your answer is going to get closer to the actual answer. So if you use one more trapezoid than the question is going to be asking, it means that your answer that you're going to be getting is going to be different from my answer. But sir, it's not better when you get the answer closer to the actual answer. It's better when you use what the man them ask you to use. So remember, the number of trapezoids, the number of ordinals is going to be one more than the number of trapezoids. And I'm going to say it again. Nestor asks a question, sir, I understand when you're teaching us, sir, don't get me wrong. But sometimes, sir, would I prefer if you could relate it to real world maths, which is what I do, so that we can see it a little bit better. Hear what I said to you. And she said this to me after I tell her to put up her 4 fingers. Put your thumb into, and Ramesh, Alton, Tiana, you weren't here. Put your finger, your thumb, raise one of your hands, whichever, left or right. Just one. Place your thumb into the palm of your hand so that you're only seeing 4 fingers raised. You see the 4 fingers? The index, the middle, the ring, and the pinky winky? Those are what are called my ordinals. How many of them do I have? That's a question. 4. All right, good. Then now we're going to count the spaces between fingers. How many spaces do we have between fingers?
3.
3. So the number of fingers, index, middle, ring, pinky winky, are my ordinals. Between the index and the middle is a first trapezoid. Between the middle and the ring is a second trapezoid. And between the ring and the pinky winky is a third trapezoid. Look at the formulation, and I'm going through the formulation again. Yes, Shaz, I know it's your show. I'm coming to you. Look at the formulation again. You'll recognize that the first one and the last one don't have no 2 in front of them. Only the other 2 have 2. Okay. Because look at your index finger. Your index finger does not have 2 bases to work with. Only 1 base. Where's the base, sir? The base is to the middle finger. But when you look on the middle finger have left and right base. That's why it have a 2. When it, so when you look at the ring finger have 2 left and right, 2 bases left and right. But when you go to the pinky winky don't have nothing to the left, it only have to the right. So that's why the first one and the last one is not affected by the 2. Only the middle ones are affected. All right. So if you understand the difference between ordinals and trapezoids, then you'll recognize this. Now, hear me out. My final thing before I make sure I go back, Sometimes the question will say, use trapezoidal rule to estimate BAM, comma, n equals 3. You know that n is the number of trapezoids. But sometimes I'm not going to tell you n equals 3. Sometimes I'm going to tell you with 4 ordinals. It's the same question. It's exactly the same question that I would have on the screen right now. It's just that I'm telling that they are ordinals versus trapezoids. Ordinals, 1 more than trapezoids. All right. So, and you see what I did right there in the notes? I said ordinals are -1 Because remember, no, my delta x said that the width of the trapezoid is going to be 1. The width of the trapezoid is going to be 1. I must start with my lower bound and end with my upper bound. So when I move one space from my lower bound, which is -1, and I move one space on the number line, the next number going to be 0. And when I move one space on the number line from 0, I must catch a 1. And when I do a 1 and move one more space, I must catch a 2. Can I move from 2 and jump somewhere else? No. Why comes? Because my upper bound is 2. Continue, Charles.
Yes, sir. So the next, well, yes, as I was saying, I thought it was we should go up by 1, but when I saw that didn't work, I thought about the decimal, and at first I was saying maybe it should go up by 0.5, but then I realized it would still be off. Then Yannick and I were having a little conversation, and she said something to me that made me look back at the notes, and then that's where I saw that part that you have in red there. And
Width of the trapezoid?
yes, sir. So when I did my own, I had gotten 2/5. So what I did was converted it to the decimal form, and that's how I found out how much it should go up by. And that's after that. Yeah.
Right, stick up in. I know why you converted it, because when you converted it, you recognize that every time you were able to add 0.4 to it. True or false?
Yes, sir. True.
And then so you recognize that each step is 0.4, 0.4. Very good. Now, you may not have seen it in the fractional form, but it is very clear in the decimal form. True or false?
True, sir.
Good. Now, let me just caution you on something here now, which is why I wanted to stop. That is perfectly fine. It is perfectly fine, because I would suspect also that when you're doing the substitution, you would have substituted the decimal form. True or false?
True, sir.
All right. Now, hear me out now. If I gave you a question like that with a terminating decimal, like 2/5 is a terminating decimal, 2/5 is 0.4. It is a terminating decimal. We don't have a problem with it. Not a problem in the world. But when I give you a decimal that is recurring, like say you had 1/3, where we have 0.33333, you better substitute the fractional form into your function. Why, sir? If you only substitute 0.3, your values are going to be off. When you have a terminating decimal, you can work it so. But when you don't have a terminating decimal, it can't work. Can't work. So I always say to students, substitute the fractional form. When you substitute the fractional form, you have to remember, is it terminating or recurring? Because you see, when you get questions like this, remember what Yannick said last class, Sash, talk truth. May I look on the past papers, and every one of them have something on it. This question is going to come. You know how I felt like a please daddy when I was marking the Calculus 1 papers. And I saw how people dissected, say, for example, question 1, when they wordify the little stationary point. On a whole, the class mashed it up. On a whole. Not everybody got the 20 out of 20, but on a whole, you understood what the question was asking. This is where I want to get to. I don't know if the man them going word up for the trapezoidal, but I am getting into every nook and cranny of this thing so that when you not catch it anywhere them give, only can do it. All right. Okay. So me correcting that now with you, Charles, I would mark it full marks, in this case, because this was a terminating decimal. But had it been a recurring decimal like 1/9, which is 0.11111, if you only use 3 decimal places here, so it going to throw up your answer. Now, hear me out. Hear me out. If the question,
Sir, before we air it out, you're talking if it was a reoccurring for the width?
yes.
Yes. Oh, okay.
Yeah. Hear me out now, though. The converse is true that you could use a decimal form if the question had said to you, given your answer to 2 decimal places, then you could work in 4 decimal places for argument's sake. And then when you reach your final answer now, you just round down to 2 decimal places. You follow me?
Yes, sir.
So I'm saying to you, if the question says to you, leave your answer to 2 decimal places, and you choose to use decimal forms to substitute in, just make sure say you use both 4 decimal places. You follow what I'm saying? So that you will capture as close as possible to the answer, the actual answer. Say them say to you, use 2 decimal places, don't round off to 2 decimal places in the whole calculation. Some teachers say you round up 1 more and use 3. Me always tell students use 4. Be on the safe side. Fair enough? Continue, Charles. So
Yes, sir.
Yeah, go ahead.
So when I substituted the values, I had to convert them back to fractional form because they had a whole heap of decimal points, sir. So, yes, sir. So after I converted them back and I did the calculations, then I got my answer. And when I did the actual one, it was, well, I realized that the trapezoidal rule, it was overestimated, sir.
Very good. Very good. Now, so that concludes your stuff, Charles?
Yes, sir, for that question.
Thank you, honey. Thank you, honey. Now, I like what she said at the last part, because what she said is that she went ahead and did her calculation. And when she did her calculation, she recognized that there was an overestimation of the stuff. Now, it comes back to the question that Yannick asked. What was the question, sir? It's an approximation. It's an approximation. So because it's an approximation, you are not going to get the exact value. Sometimes you get the exact value, you know. Sometimes you do get the exact value. Don't get me wrong. Yep, sometimes you do. But it depends on what it is that you're calculating. So sometimes you do, sometimes you don't. Sometimes you do, sometimes you don't. So I'm happy about that. Is there anything that anybody else did and was able to unravel it that Charles didn't speak about that you want to share with the class?
No, sir.
Okay.
For the first question, when I did the ordinals and substitute in the function, my question is, should I leave that fraction as though it is and not work out the fraction to get decimals? Because it's
just leave the fraction as it is. Yeah. Leave the fraction as it is. We're not big students, so they can't work fractions. Leave the fraction as it is. Come on.
Okay.
Leave the fraction as it is and just work with the fractions.
All right.
Yeah, man. Do that. You see, we're working smarter, not hard. And for me, if I know I can use one method, 1 stone and kill 2 birds, don't give me 2 stones. Because it means now say, me go have 2 stones, chances are by the time I shoot 1 bird, the other one will go fly away, and it will make it more difficult for me to catch that one day. So I try to work very smart and not hard. Use a fractional form, hear me out. If you have one good calculator, not the Kenko with Mr. Chin said. If you have like a natural display something, You just put it in the calculator. Put it in the calculator and you're good to go. Good to go. All right. Is there any other suggestion for the question before I actually do the question with you? All right, let me just pause and say something here. And just to overemphasize how important it is that when I give you questions, sometimes I don't have these questions in an after class, immediately after class. I will just log off and just go hold a little lay down and then jump up and spend another 3 hours preparing notes for you guys and writing questions. And I do this because I want you to be able to have information about what it is that we're doing to help to concretize the whole teaching and learning process. I'm very aware. I don't want nobody to tell me, because I am very aware that some of you don't even do as much as to open the document that was sent, to the point where some of you won't even say thank you, sir. When you did problem stats, you would have done a topic that is called regression and correlation. And I'm going to say there's a strong positive relationship between students that participate in class and the grades received at the end of the semester. The more you participate, meaning you do your question and you talk in class support and so on, you try to clear up your misunderstanding support and so on, you will get a better grade. There is a very strong positive correlation with that fact. So for those of you who continue to be passive learners, I really want you to speak up. Ask me questions. If something is not too clear, nobody in the class can say, geez, him don't see, them can't do that. I will finish them for you. Them can't do that. Me want you to ask me the questions. Please and thanks. All right, with that said, let's go. Let's go. So, was this a question, by the way?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
I did not see that. Okay, sorry. I did not see that one. Because I responded to you and I was hoping that you would have. Oh, yeah, 414, you're right. Oh no, 440 Media Road. No man, 440 million people them store I try to spend some money. Yeah, true. Yeah. Let me just check something here. So, all right, I will check to see if what you have is what I have. All right, let's go. All right, so that was a side talk with a student in the class. Let's go. Okay, so my formulation says delta x over 2. So we will always have delta x over 2. Yes, that's a part of the formulation. Now, this inside my square brackets can get smaller or it can get larger depending on what. Let me see if you're thinking with me. This can get larger or smaller depending on what?
The width, sir.
Mm-hmm. The width or the number of trapezoids. All right. So now, how do we calculate the width? The width is going to be delta x, and it's going to be b minus a over n. B minus a over n. N is the number of trapezoids. Sorry, they never tell you how many trapezoids. Okay, but they did tell you with 6 ordinals. The ordinals is going to be one more than the trapezoid. So if it's 6 ordinals, that means I have 5 trapezoids. So that's why I have 5 down here. So upper limit is 3, lower limit is 1, 3 minus 1 is 2, and n is 5. So this tells me the width of the trapezoid. So it means then, you remember, no, the width of the trapezoid has to be consistent, you know. You can't have one width to be 1 and the other one to be 2/5. No, man. It must be equal. Must be equal. Must be equal. And you know, I won't say it because it comes to my mind. Sometimes I wonder, I mean, I've had quite a number of workmen that have done pieces of work for me. And I remember one workman was building something for me, you know, some cupboards for me. Well, not building the cupboards, was installing some cupboards for me. And I needed to go and purchase some stuff. And you know, the piece of board them to support the thing and rate it. Yeah, and he said to me, all right. And he take out him tape measure and he measure it and say, all right, bam, 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 bam. All right, we need all this. And I say, well, man, I know so much something we need. He say, yes, teach, that we're gonna need. I say, give me a minute. I say, all right, 12 inches make 1 foot. I take the tape measure, I measure it. I do that, I do it. I say, all right, boom. We say, yeah, that we're gonna need this. So I say, how much you tell me again? He say, all right, yeah. He say, how much you get when you do it? He say, I get the same amount like him. He say, all right, I tell you, a long time I listen to teach. I say, yeah, man. But guess what? The truth of the matter is, if me give the man one question like this, the man can't do it. You understand? But the man know him work and know him from a calculation. Yeah, that's true. So, if you're building a wall, and you have somebody that is credible. This wasn't the question, guys, that I gave you to do for homework.
Yes,
this was
sir.
it? Okay. It's just that I have another question in mind for you. I think I wrote that question.
So it gave us 2 questions actually.
Oh, okay. Because I know I gave you one with that exponential function.
No, sir.
Okay. Well, I have an exponential function I want to give you. Yeah. So if you ask someone to build a wall, the man have to go measure the wall, you know, and then the man will measure how many columns in going put in the wall. So the man may say, every 6 inches, you're going to have a column. But if you're going to have a little piece out there, so the man say, okay, every 6.5 inches, you're going to have a column. So you may not know how to do the calculation, but trust me, the man out there, if he's credible, because somebody might build wall and now put no steel in there, and when heavy rain come, the whole wall tumble down. And trust me, 1 block and 1 bag of cement and rough sand and granite sand for smooth out are not cheap money. So make the man then put the steel in the wall, right? So you have to understand the nuances, which is the point I'm making, in doing your calculations so that when you start, you're good to go. You know, have no problem. And how I'm teaching this stuff, you know, any way, shape, or form, the man and be the question, you can do it. Let's go. So you know what your delta x is. Now, what I did here was to show you that my delta x is going to be, my delta x over 2 is going to be 1/5. Because remember, you know, even though I have my delta x over here, my delta x is going to be 2/5. But I'm dividing 2/5 by 2, so I'm going to end up with 1/5. So in the formulation, right here, when I have delta x over 2, I'm going to have 1/5. Let me show you if this thing only moves. Will only move. Right, so this is where I end up having my 1/5 now. So remember, you know, it's not delta x you input right here, so it is delta x over 2. Delta x over 2. All right, so now that I've worked out the width of my trapezoid, and I know that it's going to be 2/5, my first value is going to be 1. Why 1, sir? 1 is my lower bound. One is my lower bound. So I'm going to start with 1. And every increment thereafter, I am going to go up by 2/5. Sir, how do you do that? Good question. No, 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 no. Can you open today, please? What's your
Sir,
yes, honey?
you can sponsor me one of them good calculator.
You know, say any COVID never did keep. I would have tell you say, yeah, you know, I had a very good one, but I had a very good math student, and she did. Where's the stuff? I just opened it. I had a very good math student, and she did so well that I took up the calculator. Oh goodness, I love that calculator. And I just gave it to her. She said, "Sir, are you serious?" I said, "Yes." She did very well for the associates. I said, "You know, you're going to need this calculator for the bachelor's." And I gave away the calculator. You see, if I did have one more, I would have said, eh. But trust me, hold on. Ah! But guess what happened now? The one that I'm going to project here, I don't know what is happening. Okay, the one that I'm trying to project here, you will not be able to use this type in the exam because it is programmable. So you can't use the, sorry, I'm distracted because I'm trying to open up something. You can't use a programmable calculator in the exam. You see, all of them fancy something here, so it's programmable. So for argument's sake, if I want to get some values for the function, say e to the x squared, I can go to my table. Come on, don't do this to me. E to the x squared. Oh, come on.
Sir, that is not e to the x squared, you know.
Oh,
That is
sorry.
e.
That's why. That's why it
Yeah.
gave me that thing. Yeah. Thank you. Thank you,
And
man.
you're not listening, sir.
Now, I don't know what is wrong with him, you know. Jesus. E raised alpha x, and no, I'm wrong again. E, put that right there, so alpha x, and then square that. Okay. And then no, I'm going.
So, sir,
Put,
wasn't that e to the x over the ln button, sir?
yeah, that's what I did. But it's e to the x squared I wanted.
Okay, sir.
But I don't know what, I don't know. Anyhow, whatever. I'm not going to waste my time looking at that. But anyhow, yeah, so these are my values here. I mean, not values, sorry. My functions that I can go ahead and use, you know, to do what it is that I need to do. I can plot a graph of, let me see if that works, number 5. Let me see if this one works. Graph the function e to the x squared, syntax error. Let me go and graph the function e to the x. Nothing is working for me today. What is wrong? Let me go and grab the function e to the x and draw that. Okay. Something clearly is wrong with what I'm doing tonight. say I'm graphing the function 2x plus 3, and if I draw the graph, syntax error, press exit, something is wrong. I don't know if I have access to, no man, I'm supposed to have graph the function 2x plus 3, y is equal to 2x plus 3. So we're going just anyhow. I have the actual stuff, so I mean I can look at it. All right, let me go to, I think is one I need to go to in order to do my stuff. Yeah, let me see if the calculator will work. Delete all, F6 to clear, delete all, F6 or F1 to clear. You know, the function, I believe the function on this thing is different from my one, you know, because I normally press F6 to clear. All right, whatever it is. So where was I? I was showing you, I'm sharing the screen. Oh Lord, I don't have it in front of me. It was, is it 3 minus 1 over 5, right?
Yes, sir.
Yes, sir.
Yes.
All right, so 3 minus 1 over 5 is 2/5, right? So I was saying to you, if you can invest in a natural display calculator, it will make life so much easier for you, because I'm able to put my fractional form in the calculator, and it gives me my fractional form. It doesn't give, and if I want to go to decimal, I just press my F to D and I get my 0.4. Press back my F to D and it gives me my 2/5. Now, if I'm doing this stuff, I know my first limit is 1. So it's going to be 1. Sorry, going to be shift answer plus 1, and it's going to give me 7/5. It's what I'm saying, because I'm adding 1 to that, so I'm going to get 7/5. And if I add, if I say answer plus 2/5, answer plus my 2/5, which is what I know my value would be, it then gives me 9/5. And then answer plus 2/5. Since I know 2/5 is my constant there, it gives me my 11/5. And if I say my answer plus, you don't have to do it this way, I'm just showing you, and your other calculators can be like that too. Answer plus 2/5 is when it give me 13/5. And then my answer plus 2/5 is going to give me my 3. And I know that's where I'm going to stop, because I know my 3 is my upper bound. All right. So what's the point I'm making? What's the point I'm making? These values here, I was able to calculate using my calculator. That gives me and confirms to me what my value is supposed to be. 1, then 7/5, then 9/5, then 11/5, then 13/5, and then 3. Those are my ordinals. What do I do with those next? I'm substituting those into the original function. Recall, f of x is equal to 1 over x. Incidentally, you notice I have dx over x. If I remove this dx and put the dx to the side, I'm going to have 1 over x. So it's really 1 over x dx, but I can call it dx over x. Very important that you recognize that. So I'm going to go ahead and substitute my values into the function. Remember, you're not actually calculating the integration. Remember, you're not actually doing the integration. You are going to be substituting these ordinals into the function every single time. You're not saying adding 1 to the power divided by the new power. Go. So let's go. So I'm identifying the function. I'm identifying the function. And when I identify the function, Okay. So where it is. Oh my Lord. Hold on, guys. I'm trying to make my life easier and oh, come on. Clearly, they don't want me to be great. Oh man. All right. I was trying to find my remote for the mouse. So anywhere in my function, my original function, I see x, I'm substituting my ordinals. Anywhere in the original function, I see x, I'm substituting my ordinals. Anywhere in the original function, I see x, I substitute my ordinals. Let's go. 1 over 1, 1. That's my answer in blue. 7/5. 1 over 7/5. Oh, this one easy. All you need is flip and invert. So we're going to become 5 over 7. See here, 5 over 7. But I have to multiply that one by 2. This was the first one, and the last one I don't multiply by 2. So you're going to be 2 5 over 7. Because when you have 1 over fraction, you just invert. 1 over 11 over 5 is going to be 5 over 11. So 5 over 11 times 2. Oh, sorry, I skipped 9 over 5. Forgive me. 9 over 5 is going to be 5 over 9. So it's going to be 5 over 9 times 2. See there? 5 over 9 times 2. Then this one going to be 5 over 11 times 2. And then the other one going to be 5 over 13 times 2. And then the last one is not going to be multiplied by 2 at all. It's just going to be 1. It's going to be 1 over 3, which is 1/3. All right. So look at what Sir did. I think I do this question 2 ways. I think the last one we did. I didn't multiply, right? I didn't multiply by 2 until I get into here. So I'm showing you different conventions so you can decide which of the conventions you prefer. So that's why I deliberately not multiply by the values here and just put it inside the formulation there. So you decide where you want to multiply your 2 by, all right? So I just decided that I was going to multiply it in here, so I was going to have one calculation. So this one is going to be this one. Then this 10 over 7 is here, 10 over 9 is there, 10 over 11 is here, 10 over 13 is here, and then 1/3. And when I add up all of those, you know, I can't escape it. Even though I add up all of them functions here, I mean fractions here, I'm going to end up with something looking like a fraction, a decimal that I can't get rid of. Multiply by 1/5, I'm going to get 1.110. Party, you sent me 1.01. That means something is off slightly with what it is that you have done. I'm happy though that you got close to the answer, but I'm double checking. Yeah. You're sure that 0 is supposed to be?
Sir.
What you got? 1 point, what you got for the answer? 1.11?
Yes, sir. Same thing.
Nice, nice.
But the thing is, I use decimal straightforward.
Oh, okay. Oh, all right. All right, hold on. Let me just, all right, hold on. All right, guess what happened now, guys? Remember, before you multiply these 2, you have to substitute the values first into the function and evaluate that value first. When you evaluate the substituted value in the stuff, in the function, then you multiply by 2. Please don't go ahead and multiply 2 by the ordinals. No, you have to substitute the ordinals into the function. Substitute the ordinals into the function, then you multiply every one of them by 2 except for the first and the last. Understood?
Yes, sir.
All right. Why do I have that twice? This line and this line is, I don't need twice. I do not need you twice. That is it. Was that the other question?
Yes.
Yes, sir.
Yes,
Okay,
sir.
what is
Yes,
what
sir.
nice. What's the answer for that one? Drop it in the chat, please. All of you drop your answer in the chat, please. I don't want to tell you. I want you to drop it in the chat. I'm watching. Those who not come yet. I'm watching. Okay, I'm seeing one. Next. I might well assume that there's only one student in the work. Okay, I said 2, I said 3. Okay. Ah, cute. 4. Next. There are plenty enough of you in the class, you know. Hello, waiting on you. Hold on there. So are you saying to me that it's only 4 students with a question? When I know say we will not do it and just move on, don't? Am I to understand that you guys never did the other question? Talk to me. I know there are 3 students who weren't in class to have the full understanding, but what about the rest of you? Come, talk to me. I need to hear from you. Aviana, Andrew,
Yes, sir, I have to rework my rework the question.
Aviana, I'm going to shake
fun
out,
initially.
I'm going to shake out your lunch money for tomorrow. Say don't eat no lunch tomorrow. Davia Russell, Miss Davia, unmute for me, please.
Sir,
Where's my work?
sir, I wasn't on class.
And you know why I call you know why I calling him so gingerly a while ago? Because I have not been seeing you at my classes. What is happening?
You haven't what?
Me nah see you at the class them.
Sir, I've been to class, it just wasn't on Tuesday's one.
Okay. Remember that it's very close to home here. So I need to see you participating a little bit more than you are. You're a little bit
Yes, sir.
on the passive side. Thank you, please. Lexton, oh, you did say that you got stuck. Ramesh, you weren't here. Christy, all right, I'll pass you. Ryan, I know you were in traffic last time. Hold on there. All right. Okay, that's it. All right, so I'm going to project what it is that we did. I'm going to project what it is that we did. Then what you should have done. Let me just jump to the answer and see if I'm, yeah man, one true Sash. One true Sash. What, Sash? You eat lunch today, Sash?
Yes, sir.
Let me ask you, how you feel you do the question and it came down to the exact answer that sir have? Talk to me.
I feel bright.
Same way, so. Same way, so. Let me see if anybody has got the exact answer as 12.18. The actual answer is 12 units, yeah. So the approximation gave you, so it over approximated the stuff, yeah man, fair enough. But let me see how many of you got the approximated answer to be 12 point, where's my chat? 12.18. Okay, I'm using two. Thought I said tomorrow. What is that? I'm using two devices and I think the message is coming in into the other. Where you get 3/5 from? Hold on before we raise you up. Okay, that was the delta X. Yeah, but that you don't reach your question, you don't reach the another one, the man. 3/5 for the first part of the something. We want to go all the way down. All right. Right. So I recognize that you did that multiplication before the stop. Very nice. All right. Okay. So I'm feeling very comfortable in that you are understanding what is happening. For those of you who attempted the question, just allow me to go through the question in its entirety to facilitate those in particular who weren't here and those who made some silly errors and those who only reached delta X. Yeah, go ahead.
Sir,
Yes, honey.
I realize now why, well, I realize now why you say use the fractional form. I gave it another question, but my answer using the decimal is 9.1, which is lower than, much lower than.
But it's fine. I'm happy that you made the error now than, when it's an exam to make the error. Yeah, man. So please, just go through with the fractional form. It may take a little bit more, but guess what? It will give you the marks. Go through the fractional form. Please, I beg of you. All right, let's go.
Sir, hold on. It says, hold on. What happened to those who don't do it in fractional form? Because I don't have the calculator to convert. So I use all decimals.
Oh, yeah, that's fine. If you use all the decimals, you'll be fine. But who has time to write down all the decimals in an exam?
I have to.
Okay, fair enough. Fair enough. Yeah, man, if you use all the decimals, you're good to go. When calculator did just come out, which form third form. And what we had was adding machines, and then I had to use some things called 3-figure and 4-figure tables to do with stuff. Similar to when you were doing program stats and you had to use a chi-squared chart and them something there. Yeah. So when we have to find sign of something, we have to find it on the adding machine and then looking at one book to find out what the actual answer is. So when fourth form came now and I got my first scientific calculator, so that don't stay in my bag. My scientific calculator in my top pocket. You know why? Because a man will move with the calculator, because not everybody in the class have a scientific calculator. No, man. So I have to walk with my scientific calculator like I'm a wallet. Right? And funny story, that scientific calculator took me right through university. Trust me, that became my appendage. So what I had to do, yes, Sash, before getting that scientific calculator was to write down all the decimals so that I don't miss the stuff. But it's time consuming. But if it works for you, sure. Let me just put in a plug here. Remember, students, that we're not doing an online exam again, where it is that you can have access to maybe a calculator on a computer or a calculator on a tablet. or access to your notes or whatever else there is, you know, little jottings, whatever it is, the internet, whatever it is, everything now needs to come from memory. We're going back to the days when we have to memorize stuff. And why I'm putting that plug in is that I know I spoke about it last class, and I'm going to say it again. Some of you, when online came in, you were just beginning your second semester of the associate degree program. Is that true or is it false?
Sir, we got halfway through the first semester, so we continued the rest of the first semester. No,
it was second semester, Charlene. It was second semester.
Yeah.
Mm-hmm. You guys came in September, and by the March, halfway through the second semester, then have to put another halfway in the semester, and the semester they kind of stretched out. Oh my goodness, I was under pressure. All right. So you guys only had 1 semester of experience in doing face-to-face exams. And to come and ask you now to do the face-to-face exams, I don't want any of you to go to foolishness on the paper. So that's why I want you to start working from now. I like what I've seen, you know, and that's why I'm making a concerted effort to watch the WhatsApp group coming in to see the questions that are being posted there. I like what I see. People are working their papers. I cannot tell you, oh crap, I never said it out. I cannot tell you what the people them went to send. Please, I depend on you. I depend on you. You are so selected here because you would have done well enough in Calculus 1. And I'm expecting all of you to pull through for Calculus 2. All right, let's go. So now it says approximate the area beneath f of x equals x squared plus 1. Whoa. You notice them say the area beneath. Thank you, Sasha, for putting your unit squares to the stuff, because you're actually doing an integration. So the unit is going to be squared units. It is squared units. So the question here says, see here, so area. So once you talk about area, squared units. Once you talk about volume, it's going to be cube. So for those of you who never put your unit side of your answer, fix it up. Squared units. All right, let's go. So approximate the area beneath f of x equals to x squared plus 1 on the interval 0, 3 using the trapezoidal rule with n equals 5 trapezoids. Okay, clear cut. N equals 5 trapezoids. Fair enough. Let me tell you something. You know, speaking of which, you know, I'm going to see if I can find it and learn it and then come and talk to you about it. I remember going to a math conference some years ago, and it so happened that the Jamaicans were gifted, well, 2 of the Jamaicans, Mr. Rukud and myself, were gifted with 2 colorful calculators, programmable. Those calculators can't use at all. It is so advanced that I don't even use it. But I remember when they demonstrated the calculators to us. I mean, and that's why I think I just love Casio. Casio is like the prodigy in calculators. That conference we were in, wherever we were, and what they did was to say, for example, take a picture of a flower. I'm using your cell phone. You took a picture of a flower. And when you took a picture of the flower, they superimpose the flower, the picture of the flower into the calculator and use, a drawing tool to outline a section of the curve in that flower or on that flower. And then use a calculator to generate the equation of that line, the section of that curve on that flower. And from that, we could do a whole lot of calculations, a whole lot of calculus out of it. Why am I saying this to you? I could go and look at the topography of, say, a piece of land along the north coast, beach land too, and I can take a picture of that topography and I can say, superimpose it and calculate the equation of that topography. And then I can use the length of the piece of plot, the plot of land that is going to be sold to get my upper bound and my lower bound. And I can actually calculate the area under that curve that is formed by that equation. And out of that, I can tell you how many square footage, possible square footage you can have if you want to build a resort, for argument's sake. This is a level of mathematics that is out there, and these engineers, and the likes are actually using to do the calculation. As a matter of fact, we don't have to literally sit down and do the calculation. They go and they use their device and it tells them automatically. When they do their quantity survey, it tells them exactly okay, bam, this is 342 square feet. Okay, but hear me out now. You see the 342 square feet that you get, that is only for the ground floor. So you now can decide, the quantity surveyor is now going to come in. Nesta, this is for you, because you say you want to realize something. So if when they do the square footage, let me use a rounded value. If when they do the square footage, they get 2,500 square feet, the 2,500 square feet will be on the ground floor. And they can say, here the plan. What if I go 5 stories? It will be 7,500 square feet, because it's going to be 2,500 square feet times the 5 floors. Now the town planners may say, why only go 5 floors? If you build this foundation with this sort of specification, you can go to 10 floors. So you can say, okay, I'm going to have a 25,000 square feet. Of the 25,000 square feet, I can get 250 rooms. And I can get a big dining room. I can get 3 dining rooms that can house 200 guests at a time, plus beachfront. So this is how these people do their calculations before they start building, because all of that information will now need to go to a financier who will say that, okay, the total cost to build this property is going to be X amount of money. All right? Mathematics, approximation, because the man them now actually go out there to go dig down to see how far you can go. No, they might do the approximation, the integration to find the area under the curve using an approximated value, and they can say to you, this is what is going to be. This is what is going to be. All right? Now, real life. That was real life. Let's go. So now we know that our lower bound is 0, our upper bound is going to be 3. We're supposed to be using trapezoidal rule. We know that n is equal to 5. We first need to find the width of the trapezoid. We need to find the width of the trapezoid. We need to first find the width of the trapezoid before we do anything. Now the width of the trapezoid is going to be my b minus a, which is 3 minus 0, which is 3, all over the number of trapezoid, which is 5. So I'm going to have 3/5. So the width of my trapezoid is going to be 3/5. My first ordinal will be 0. My last ordinal will be 3. So I'm starting my first ordinal, which is 0, and I'm counting 3/5 up every time. Then, sir, why I see 3/10 right here? So me soon talk to you about the 3/10. All right? So why, okay. I soon talk about the 3/10. Let me just order this thing a little better, cut, and then no, undo. And then I paste that here. All right. So I'm looking at my I'm looking at my ordinals. My ordinals will be 0. Then the first one is 3/5. When I add 3/5 to 3/5, I'm going to get 6/5. When I add 3/5 to 6/5, we're going to get 9/5. You notice what is happening? The denominators are the same, so I just add my numerators. When I add 3/5 to 9/5, because the 5s are the same, I just add the numerators. So 9 plus 3 is 12/5. When I add 3/5 to this, I'm going to have 15/5. Also, but 15/5 is 3. Yes. So each width of the trapezoid is 3/5. Let's count how many. The commas will tell me that I have 5 trapezoids. All right, never mind, Papa. So 1, 2, 3, 4, 5. So the total set it has 5 trapezoids. I'm going to have 6 ordinals. 1, 2, 3, 4, 5, 6. So recall what my function is, x squared plus 1. I'm substituting each of my ordinals into the function given and evaluate them at that point. So f of 0 will be 0 squared plus 1, which works out to be 1. F of 3/5 is going to be 3/5 squares plus 1. Trust me, you're going to get 34/25. Then I'm going to move f of 6/5 is going to be 6/5 squares plus 1. Trust me, you're going to get 61/25. Guys, I'm going to encourage you to do your question in the fractional form. It saves time. It makes life much easier in the end. Then I'm going to do 9/5. So I'm going to have 9/5 squares plus 1. I'm going to get 106/25. Then, sir, we're going to write it in a proper fraction. We don't believe in writing a proper fraction because we could stay this up for now. Write this up. All right. Then I'm going to move to 12/5. 12/5 is going to be 12/5 squares plus 1. So by squaring them, I'm following the pattern of the function given. All right. So I'm going to have 169/25. And then my f of 3 is going to be 3 squares plus 1. I'm going to get 10. Now remember, the first one and the last one will not be affected by the numero dos. They will only be affected by the inner ordinals. All right. So I'm going to have this function. So let me explain the 3/10 now. Remember, in the formulation, I'm going to have delta x/2. I'm going to have delta x/2. My delta x tells me the width of the trapezoid. My delta x/2 tells me what it is that I'm adding. Tells me what it is that I'm, sorry, not adding, what it is that I'm going to be multiplying by my sum. So I now have to divide it by 2. Sir, every time you have to divide it by 2, yup, good to go. Every time you divide it by 2. So having found delta x, it's going to be it's not going to become delta x divided by 2. It's not going to become delta x divided by 2. Very important. Very important. Let's go, because I'm going to give you some work to do in class. Even me, I'm going to make up the question and then struggle to do the solutions in class. So I'm going to have 1 plus 2 times this, plus 2 times this, plus 2 times this, plus 2 times this, plus this alone. See it right here, so? And trust me, when I do all of this, I'm going to get 203/5 times 3/10, and then I'm going to get 609/5, and I'm going to get that as my answer. All right? Now, are there any questions?
Sorry, can you scroll it back a little bit, please? Little more. All right, thanks.
No, no problem.
Okay, scroll down a little bit.
Let me know when you finish, because I need to give you a question to do. And again, congratulations to those who attempted these questions and got them right. And for those of you who made errors, I hope that you see your error where you went. I know Yannick said you see hers. Charles, you said that you made an error. You see where you went wrong?
Yes, sir.
Nice, nice. All right, I'm going to be moving. That was a mean value theorem. Oh Lord, sweet Jesus. All right. I will have to write another question. Let me All right, let me write a question. Example 4. I'm just lazy a while ago, and I just changed the function to e to the x squared plus 1. We had x squared plus 1. I'm going to give you e to the x squared plus 1. And maybe you can get decimals right. So I'm saying, giving your answer to 3 decimal places. I'm going to give you 10 minutes, right? I'm going to step away briefly, and I'm going to see if I can come back and start my solution. I'm going to step away briefly. Start working for me, please. 10 minutes. Example 4, approximate the area beneath the curve. F of x equals BAM on the interval 0, 3, using the trapezoidal rule with n equal 5 trapezoids, giving your answer to 3 decimal places. All right, let's see how well that works out to be. Thank you. What happened, Sean?
No, I thought you were trying to talk, sir.
No, no man, no man, no man. All right, thanks, Sash. All right, give me another 2 minutes and then we'll move on. Everybody finished?
Not as yet, sir.
One word. I'm almost finished. Print mine now. Got up, I intended something. I'm now back. Wow. Wow. Don't worry about it, Papa. I just make up the question a while ago. Oh, no, man, you're good, man, because I'm getting those numbers too. I just made the question out of my head a while ago. So, Wow. Let me, those are the numbers that I'm getting. How you see with those numbers? Are they the same numbers you're getting?
Yes, sir. Yes, sir.
Mm-hmm.
Where the number that come from?
Yeah.
Messy.
Sir, you know, see that last one there kind of throw me off too, because I wonder when I get such a big number.
Mm-hmm. Yeah, man. You see, as I said before, from last semester. Yes, please.
Sorry, you sure the last part of the last number, right?
This one here, so 79?
Mm-hmm. What was the number after the 9?
No other number.
That was
But
a flat number.
it was a flat.
That was a flat number, sorry?
Yeah, it gave me 22,026.46579.
No, may I
And
go
the
see if my
number they look
calculator
different, sir.
broken.
Say it again, Lexton.
No, it's actually Alton. No, I was just saying them. Oh, I realized. I see what I did. It's a fraction in substituting the other in the function. I didn't put the fraction in bracket for the R square.
Right.
Okay. Okay. All right.
Sure.
Then
You're not finished, right?
we're not finished yet.
All right, when you're finished, then I'll see what the final answer is.
Wait. Two point seven. 18, 828. Mm-hmm. 2.71828 plus 2 times 3.89619 11.47304 69.40785.
Sir, I have a question. When the paper is being set and these questions are sent out, they're usually worked out before.
Absolutely.
Okay. Because But we don't want to send a question on the paper where you send off at the top of your head. Sir.
Go away, right?
Think about it, sir. We always get some ridiculous numbers as the answer.
No, well, that's not true because this answer come out to be a nice one. Jesus.
Sir, from it over two whole numbers, it's a big number.
Oh goodness.
You know how long me I type numbers in my calculator before I could get my final answer, sir? Just for the add up.
Osh.
Why, sir? If you give an exam with them type of question upon it enough, go give it 5 hours because just typing the numbers alone and take up time.
All right. See, if it's her, I end up with the same answer. But guess what? I don't do those long numbers that you have. All I did was copy and paste basically the same decimals that I had from the previous one. And I have the E to the answer that I got. And I round out to be the same thing.
Very well. Yes. But I want to know, stop saying, I want to know like my question because every year group I have, them say the same something. And if I stop saying it, it's not a nice thing to say. All right?
All right, let's put it this way, sir. We're happy that we're getting them in class and not on the exam.
Oh, Lord. I had some students who say, sir, please sit out in setting the exam question. And you know, funny enough, you know, you guys have done papers for me already, you know, that they were my actual papers. I won't tell you which one.
Sir, I can pick up some of your question them from the past paper, them man. Anyone will stress me out? Mr. Shan put that one here.
No, but look at the answer, 717.207. A good number this one. How I interpret this one, you know, that's a nice plot of land to buy from somebody. A 7,000 square feet, for argument's sake. A big house, you can't get out of that, you know. 7,000. No man, think about it. A 7,000 square feet house. A whole heap of house that you can't live out that. And then if you decide, say, you're gonna go two stories atop that. You don't have to work. You just make sure you put it in such a way that the first floor and the second floor have them self-contained units where you just rent it out. And then the top floor, you can just live. So you live and people pay you to live. Pay you your rent every month. And you're good to go.
Sir. I see what you are trying, you know, sir, but the ends not justify the means.
Why?
Them bag of number that I'm typing. That could have been my plot of answer. No, sir. It's a maths question me I work currently. Right? What stress me out.
Unique, let me tell you something. And this is something that I've done from ever since. You see, when I feel very stressed and overwhelmed, like the other day, pretty recently, I remember just turning off my cell phone and going to the bed and just lay down. And while lying down, I said, I have a course delivery plan, I have a mixed semester, I have a final exam to set for Calculus 2. And I said, oh, really? And I just lay down and I didn't care about anything in the world. And then when I lay down, the whole other problem, but you have the course delivery plan to do. You have a mid-semester, as I said, and you have a final exam to prepare for. I started thinking about me flying to Dubai having swims and lobster and calamari and chicken and you name it, whatever, what else them have prepared for me to eat. And me under the cabana having a nice pina colada or some other daiquiri or whatever. And I just started thinking big. I'm flying, go to Europe. I mean, not know when I'm have the war going, you know. And I just released my headspace from all that was. And I went tell you, so when I fell asleep and I got up back, I was brand new. Brand new. So I'm telling you, sometimes when you see these questions here, just start thinking big. Just start thinking as a boy, you know, I'm gonna do this. And you know, the truth of the matter is, I suspect, I see it, I'm prophesying it, that you guys are going to do exceptionally well. And later on in life, you're gonna have people serving you your own meal. But remember, when you don't make it big in life, remember who prophesied over your lives. So when Sir say, Yannick, you know, I feel like I want to go to Dubai, not a problem, sir. And pocket money is there ready for me. Plane ticket buy, hotel accommodation done set.
Speak it into being, sir. Speak it into being.
Trust me. No man, it can happen. It can happen. It can happen. But it takes you know completing this leg of the journey. And just doing that, you know, while you work on it and just toying out your headspace. I remember some years ago, I mean, I have told you this before, some years ago, I had a student who really had life rough. And I believed in the student so much. I taught the student CXC math. And the student passed in CXC maths, and the student went on and did an associate degree in a particular area at the college. I went on and did the bachelor's degree, and the student said to me, sir, I'm gonna make a foreign flex, and I said, boy, ropes, I don't like this, you know, because rate, support, and so on. Long and short, young man made a move. Young man is married with his family. Young man came to Jamaica and said, "Mo see Mr. Sean." And I said, boy, when I get a teacher number, you know. I say, all right, so my number, give me ask him to give me a ding. And I remember when I got the message of Friday, and I called him, he said, sir, I leave tomorrow morning. I'm going to meet with my high school mates. Them know when you come into Florida. I said, funny you ask, because I'm coming to Florida Monday of next week. He said, all right, sir, when you land, call me on this number. See the number here? And I got to Florida and I said, Chuck, let me come back to Jamaica and call him. And I said, all right, no. He said, call him when he's in Florida. And I called him. I never knew that this young man was assistant general manager for one of the top 5-star hotels in South Florida. And the youth say, sir, come on and come check me. I said, all right, no problem. A long time I don't see him. So I say, you know, my wife and I drove down, and the next thing is that when we got to the front desk, he said, oh, you're Mr. Sean? I said, yes. All right, your room number is that. I said, excuse me? My what? Mark, you know, we go down to the place and don't have no clothes. So we left from up Fort Lauderdale, drive way down south. Don't have no clothes, because we didn't plan to stay over. The man said, no, you're going to spend a couple nights at the hotel. And me tell you, man, guys, I love what I do. I don't look for anything in return, absolutely nothing. And it's not that put up stay in a top 5 hotel where we're getting wine and cheese to eat. That part was nice, yes. But what was very good about it is seeing a student, knowing where the student is coming from, seeing where the student, you know, has gotten to a point where the student became assistant general manager for one of the top 5 hotels. You man, one black Jamaican boy, you know, what come from the inner city, you know, gonna foreign, gonna get big job over the people them in a foreign, you know. You understand? It was a proud moment. When I say a proud moment, when he was telling me the story He was crying and said, sir, it wasn't easy, but I made it. And me turn and see my wife start crying. I say, okay, since everybody are crying, me I forgot cry too. So they throw in another place I cry. You understand? But it's a good feeling. What's the moral of the story? I love when my students do well. I don't have to be in the equation, and I don't necessarily want to be in the equation. Matter of fact, I don't want to be in the equation, but I want to be able to see the equation. I want to see where it is that you guys become your top computer engineers, with Southwest Airline, and there's a glitch in the system, you can go and fix it. You have your big bank jobs and you make jobs for yourselves too. You don't have to go out and work for people, but you do your entrepreneurship and your new business venture, and you create jobs for yourself and live your life, right? That's what I want. And it starts here. When you feel me calculus too, when you move on and do what you're supposed to be doing. I don't necessarily need to be in the equation. I don't want to be in the equation, but I want to see the equation. I can say, yes, I had a part to play in that. So guys, please, whatever we do here is for what is to come in the future. How did I get here? Just lay down and start dreaming big. When I have problems, I start thinking of me flying somewhere where we can go and enjoy life. And it really releases the pressure that I'm going under. I want to do the same thing too. I want to dream big. And when I dream, I want to try and make on the dreams come true, and work towards it. When you get to pay, no come tell me, sir, I only work $5,000 and my bills come up to $4,900. Well, save the $100, save it. But you have to pay on yourself when you work. So just like when you take out on the tithes, on the 10%, when you take out another 10% for put on the bank, for something. You have to start from now. Little later on in life, when you finish, you can say, yes, say, we can buy one car or update my car or whatever it is. We have to start from somewhere. Right? But anyhow, that was my pep talk for the night. Question. Yes, the numbers looked a little bit off, but it kind of dwindled down to something that is a little nicer. 7,177, is a good number. This is like a practical question where some hotels are being built with their square footage to be 7,000, their ground floor to be 7,000 square feet. And how them end up getting 50,000 square feet is by building on top of those. All right. So these are some ways that we can go ahead and do our calculation. All right. I'm going to spend about another 11 minutes to end at about 9:30 tonight. There's another part of the question about calculating the errors, but I don't want to reach there just yet. I want to get you to a place where you can, fully get through this sojourn. Ryan, are you okay? To say you just silent for the whole class, Wait. Mr. QC. Christy, you all right? Fraser, you all right?
Yes, sir.
Okay. All right. Let me give you just one last one for classwork, and then next class, all being well, I can then just jump in in calculating the error, because you know what? Let me not give another one. Let me ask you here to do the actual calculation. Go ahead and do the actual calculation for me, please, guys. Oh dear. Hello.
Yes, sir.
All right, guess what? Press pause. Press pause, press pause, press pause, press pause, press pause. I get to a point in my calculation where it's going to be, it's going to involve a level of integration that is not on your syllabus. It's going to involve a level of integration that is not on your syllabus, and I'm not going to be teaching you anything unnecessarily. So press pause on that one. Forgive me, never saw that one coming. You are not required to do integration by parts, and as such, it's going to involve integration by parts. So we're going to scratch that one. All right, so it is solvable, but a person like this will only give you, so a person like this won't ask you to calculate the error for this, a person like this, because they won't, unless they will tell you, unless they will give you the actual calculation, unless they will tell you the actual calculation for this question, I mean, is this, you trapezoid to find the approximation stuff, and then they will ask you to go ahead and do the error calculation. But outside of that, no, this one's going to involve my parts and And funny enough, I've calculated the stuff, and it is way off. E to the x squared plus 1. My actual calculation is giving me 3,926.68. My actual calculation is giving me 3,926.68. And that one is giving me 77. Wow. Did anybody get this answer as Sashi said that you got this exact answer 77177 point this 207? That's a yes or no?
Yes, sir.
Did anybody else get this exact answer here?
Yes, sir.
Well, my actual is e to the x squared plus 1. My actual is 3,926. So I have to look into this one.
Boy, sir. Them they call them the hotel people, them would have vexed with you.
Oh yeah. But it's an approximation still doing, but yeah, that's true. I mean,
That's overshot by enough.
Yeah, how would I resolve something like this? Yeah, that's true. This one would have to be, well, one of the things that we could do for this one though, I don't know if any of you have seen anything like this, been to one of those hotels and see where they actually dump a section of the sea in order to build out. Anybody has been to any one of those hotels on the North Coast?
Yes, sir.
I don't want to call the names because I've been to one or two of them and I see where it is that they literally dump. And you can see what is happening because you can literally walk out to about 100 yards into the ocean, where again they build a groin. There's a particular one that build a groin there, and people will go over there to have wedding ceremonies and so forth and so on. Nice ocean view. So if you're there and you look beyond you, you're seeing pure water. And you can actually walk. You don't have to swim, you can actually walk. And the water is clear enough because what they did was to dump. So maybe that is one possible explanation. When I get the 3,000, but I don't still them say 3,000 pound land. I can get the other 3,000 out of sea by dumping. Come in, I'll lose my word. Crazy. But it is also possible, very possible. And this is where the NEPA and these other environmental people now come in to say, yes, you are allowed to dump. Funny we're talking about that. I don't know how many of you live in Portmore or have gone to Hellshire recently. Again, I remember one of those days I was feeling a little bit overwhelmed. And I remember deciding that, I'm going to take a drive out. And of course, I decided I was going to drive to Portmore and to go to Hellshire to eat a piece of fish.
Sir, the shoreline reached the parking lot yet?
Dearest, I don't know why I'm going to go Port Royal, but I'm going to tell you something. I decided that I was going to get very close to the shoreline. You know what the man them do over there? The man them build concrete restaurants / houses / whatever it is right on the shoreline. So you see, when you step into the ocean, it's a deep hole that you're stepping in. And one of the areas that I studied at university too is the environment. I vex. I tell you, so when I tell you I vex, and the people them come and say, sir, you want to buy fish? I said, I'm not buying nothing from none of them. I said, don't come to me, I'm not buying. I don't want anything to eat. I could not, in clear conscience, spend my money and see how I even saw this man, I don't know where he caught the fish, but he was gutting the fish right on the seashore, and the guttings, he just take and just throw it into the water, and you have people there swimming in it. And I stood up and I said to myself, oh, height of nastiness. And these people, all they're thinking about is their livelihood and not thinking about taking care of the environment. And I got so enraged that I said to my party that was with me, I am ready. You know where we had food? We go to North Britain with them of the KFC and the most of the pizza place down there. So, and that's what we bought to eat because I decided I'm not buying enough food up there. So, you know, the environment. So when I say dumping, you know, is one thing, but in real clear conscience, based on one of my areas of study, I cannot in clear conscience just leave the class without not saying that the environment is what provides for us, and we don't need to provide for the environment. And trust me, it mash up. Anyhow, I'm going to end here tonight. Trapezoidal is finished. I mistakenly went ahead and prepared something on Simpson's rule, which is another form of approximation, which almost looks like the trapezoidal. But I think Simpson is not on your syllabus, so it was a wasted effort. So we are looking good. We are on target for outline. I just need to let you help me. We're looking good. We are your mid-semester. You'd have seen your mid-semester is supposed to be pretty soon. Tomorrow is April. Oh, Yannick, tomorrow is your birthday. April, not that. New share. Yannick, you cannot answer me. Google Docs. Miss Yannick, you cannot answer me. All right. If you look here on your outline, oh, this one's supposed to be a very nice thing. And notice, you guys, Dan Deshandi away from the differential equations for calculus 1. I really hope you don't Dan Deshandi this one for the calculus 2. Application of integration. You have apply the mean value theorem for integration. We did that. We applied the mean value theorem. Everybody remember the mean value theorem for integration, and we have applied the trapezoidal. This is your outline. We have applied the trapezoidal rule. That's something you're not type right here. Don't worry about that one. This is not type right. Look at the. Okay, I see what they were trying to get. Look at the one that I presented to you. And this is the next thing that we're going to be looking at. It says to determine whether the actual area overestimated or underestimated, and to calculate the percentage error involved. All right. So that's going to be the next thing that we're going to be doing. An easy sum. My aim, as I told you, is just to get through the integration, not the integration, the approximation. And then now we're going to be looking at the errors. And after that, I'm going to be looking at integrals. We're going to be doing some actual integration now, but the actual integration is going to relate to volumes by slicing and rotating. So we're going to slice and calculate the volume of something that is rotated 90 degrees, 180 degrees, 270 degrees, and a full revolution of 360 degrees. And then integrate exponential functions. Why do they have this here again? Did they not have it? No, they didn't. No. So integrate exponential functions. Oh, this was differentiate exponential functions. All right. So that was to differentiate exponential functions. This one here is to, I know I saw it. Did it not say, no, this is integrate. Where am I? Right. Integrate exponential functions. We have already done the integration of exponential functions. Use the intermediate value theorem. We need to use the intermediate value theorem. So we have three things to look at. Volume. We've done the integration of the exponential functions before. Then we're going to be looking at the intermediate value theorem, which is, I mean, that's like a one class. Then after the applications of that, we're going to go back to differential equations. And this time we're going to be spending a little bit of time looking at the at some integration factor. As I said before, this was one of the weak areas for you guys in Calculus 1. And I need to wheel and come again so at least you can understand what is happening here. And then the final thing, the final thing is to look at multivariable calculus. We did some levels of multivariable calculus when we talk about stationary points. We're going to come back to some stationary points again, but this one we're going to look at the multivariable calculus, second order partial derivatives. We've done this already in Calculus 1, first order, second order. We've done that in Calculus 1. We're going to review those. Then we're going to talk about SI and matrix, which is not difficult, and define and demonstrate the chain rule for multivariable. 4, 5, 6, 7, 8, and 9, no, and 8 are really not difficult areas because we have done some levels of that already. Triple integration, we haven't done any. I think we did some double integration in Calculus 1. So it says here to define and use double and triple integrations on rectangular coordinates. And then I am going to be doing Lagrange multipliers. I have to do Lagrange with you. So we are on target to finish off all of what I just spoke about up here goes up to 1, 2, 3, 4, 5, 6, and 7. Lagrange multipliers would be number 8 and the line of regression. Yeah, so we should finish off in due time. Please, students, remember that your mid-semester is scheduled for this coming month. And I trust and hope and pray that you guys are practicing. I know some students are working already. Remember, when you maximize on your mid-semester, if you make an error on the final paper, if it compensates, the mid-semester compensates for some of the errors that you would make on the final stuff. Please, I beg of you, I will try my very best to see if I can get you a mid-semester as I did for Calculus 1.
Yes,
I'm not making any promises, but I'm going to see how best I can just, create one for you. And then to see how best you can maximize that, depending on you to do that. And out of that, we should be fine. I mean, the other topics that are left are very nice areas. I mean, Calculus 3 is really not bad. It's short, but it's a little intense, but it's really not bad. Anyhow, peace and salutation, say gentle Jesus, and have a wonderful rest of the evening. I'll send you your notes in a few when I get a little lay down, and then we'll continue on Tuesday, God's willing. All right?
All right, sir. Good night.
Good night. Take care.
Good night, sir.
Yes, sir.